Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals the square root of 16 minus x squared divided by x minus 8. The first thing to do is find the domain. F of x equals the square root, an even root of 16 minus x squared divided by x minus 8. We can rewrite the square root as a fractional exponent. It is 16 minus x squared to the first power second root, 1/2 power, divided by the x minus 8. The denominator of a fractional exponent is the root, and it's an even number here. The domain of an even root isn't necessarily all real numbers. The domain requires that what is inside of an even root has to stay greater than or equal to 0. So 16 minus x squared has to stay greater than or equal to 0 for the domain. There's also a denominator here, and the denominator cannot equal 0 for the domain. So x minus 8 does not equal 0. Those are the two conditions that need to be held for the domain. Starting with the 16 minus x squared, we can solve for x by subtracting 16 from both sides. So negative x squared is greater than or equal to negative 16. Dividing both sides by a negative 1, we'll flip the inequality. X squared is less than or equal to 16. We can take the square root of both sides. The square root of x squared is less than or equal to the square root of 16. The square root of x squared is the absolute value of x. The square root of 16 is a 4. Since the absolute value of x is less than or equal to 4, we can remove the absolute value symbols by putting it between negative 4 and positive 4. Now working with the x minus 8, we can add 8 to both sides, and x cannot equal a positive 8. Both of these conditions have to be held for the domain. So x has to be between negative 4 and positive 4, and it can't equal 8. Well, 8 is not between negative 4 and positive 4. So by simply having that is the condition, that will already make x not be equal to 8. So the domain will be this interval here of starting at negative 4, it includes its square bracket, up to positive 4, it includes its square bracket. The next thing to do is find all critical numbers. We will take the first derivative. F of x is a quotient of expressions here, so we'll make use of the quotient rule. We're going to use the version that is written as a fractional exponent for the derivative. So f prime of x equals the derivative of the numerator. It's a power rule. Bring the power down. Leave the inside alone. Subtract 1 from the power. I will call that 2/2. And then multiply by the derivative of the inside to complete the chain rule. That's all the derivative of the numerator times the denominator left alone, minus the numerator left alone times the derivative of the denominator, which will be a 1. All over the denominator squared. For the first term in the numerator, we can put all of the constants together. 1/2 times 2 is 2/2, or 1. There is also a negative and an x that can move to the front, and an x minus 8. So it'll be a negative x and an x minus 8. And there is a 16 minus x squared to the 1 minus 2 negative 1/2 power. And then the second term, minus, it's an expression times 1. Anything times 1 is that same thing. So it'll be just 16 minus x squared to the positive 1/2 power. All this is over the denominator that'll be left alone because it is technically already factored. The first term in the numerator does have a negative power. One option is to move that to the denominator of the first term to make it a positive power, then get a common denominator between the first term and the second term, and then reciprocate the overall denominator, multiply it with the numerator. Another option is it can be factored because the second term has that same expression to a different power. The factoring will usually be quicker and easier, so we can attempt that factoring. We can factor out the lower power of the two. We have a negative 1/2 power and a positive 1/2 power. The lower is the negative 1/2 power. So in the next step, we will be factoring out a negative 1/2 power. So we have a 16 minus x squared to the negative 1/2 power. Factoring is division, and division is subtraction of exponents, so we will be subtracting a negative 1/2, which is equivalent to adding a 1/2 to each of the powers here. Now, if you add a 1/2 to the first power, negative 1/2 plus 1/2 is 0. Anything to the 0 power is a 1, so that entire thing will become a 1, and there's what's left over. For the second term, if we add 1/2 power to it, 1/2 plus 1/2 is 2/2, or 1. That will become a first power, and we will have minus that expression in parentheses. There's what will be left over after factoring it out. So it'll be a negative x times x minus 8, and a negative 16 minus x squared to the first power. All of this is over x minus 8 squared. That negative power that just factored out can now move to the overall denominator to become a positive power. So it will be 16 minus x squared to the positive 1/2. There's also an x minus 8 squared. And in the numerator, we can now distribute the negative x into the x minus 8, which will be negative x squared, and a positive 8x, and the negative into the 16 minus x squared, which will be negative 16, and positive x squared. We can combine like terms together in the numerator. The negative x squared and positive x squared will cancel each other out. So it will be 8x minus 16 divided by the 1/2 power can be rewritten as square root. So it would be square root of 16 minus x squared, and then there is an x minus 8 quantity squared. We want to fully factor the first derivative, at least the portion that is not inside of an even root. In the numerator, there is a common factor of 8 that will leave behind an x minus 2. In the denominator, there is an even root. We will not factor within there. And the x minus 8 quantity squared is technically already factored. So we have the first derivative written as a single fraction. All powers are positive, and everything is fully factored, so we can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, we can divide both sides by 8. We can add 2 to both sides, and x equals 2. Now the denominator, which is made up of 2 factors, equals to 0. We can set each factor individually equal to 0. Working with the square root, we can start by squaring both sides, and square root squared is going to cancel each other out, so it'll be 16 minus x squared equals 0 squared, which is 0. 16 minus x squared is a difference of squares, so it'll factor into a 4 plus x and a 4 minus x equals to 0. And solving, x will equal a negative 4, and x will equal a positive 4. Now working with the x minus 8 quantity squared, we can take the square root of both sides. The square root and the square cancel each other out. That'll leave behind an x minus 8, and the square root of 0 is 0. We can add 8 to both sides, and x equals 8. We will now check to see which of these are in the domain. The first one, x equals 2, is within that domain interval. It's greater than negative 4 and less than 4. The next two, negative 4 and positive 4, are in the domain by being the left and right endpoints of the domain. And then the last one, x equals 8, is not in the domain, so we will cross that one out and not keep it. The other three are critical numbers. We will now draw a domain line, a line representing the domain. It begins at negative 4. It includes negative 4, and it goes up to positive 4. It includes positive 4, except we are removing critical numbers from the domain, and negative 4 and positive 4 happen to be critical numbers, so they will remove, and therefore the left and right endpoints will no longer be included. So it'll be round bracket. From negative 4 to positive 4. We can put all other critical numbers on here. We have a 2. Which it's technically also being removed from here. It's breaking the domain interval into two separate intervals. We can pick a test value in each of the intervals. The first interval, negative 4 to positive 2, we can pick 0. The next interval, positive 2 to positive 4, we can pick 3. It's a test value. We can now test the trend in each of these intervals by plugging the test value into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version of the first derivative. That would be this one here. A couple things about this. In the denominator, that even root, square root of 16 minus x squared, the domain required that 16 minus x squared up here has to stay greater than or equal to 0. And we're in the domain here. So that is the square root of a positive number, and the square root of a positive number is a positive number. So that square root will guaranteed be a positive number. Also, the x minus 8 is quantity squared, and anything squared will always be positive. So that entire denominator is a positive number. The positive 8 in the numerator is also a positive number, so everything is positive, guaranteed, except for the x minus 2. And that means we can plug our test values into just x minus 2 to determine whether the first derivative is positive or negative. Starting with the test value of x equals 0, plugging it in, 0 minus 2 is a negative number. We have a negative first derivative. That corresponds to a decreasing trend in this interval. And then plugging the test value of 3 into the portion of the first derivative that matters. 3 minus 2 is a positive number. We have a positive first derivative that corresponds to an increasing trend. So we have a decreasing trend in the interval of negative 4 to positive 2. We have an increasing trend from positive 2 to positive 4. There are 3 critical numbers on here. The left endpoint, the right endpoint, and then the 2 in the middle. Looking at the left endpoint, there's nothing to the left of the left endpoint, but to the right of it, it decreases. And that makes the left endpoint be a relative maximum. So we have a relative maximum occurring at an x-coordinate of -4. It'll have some corresponding y-coordinate. The y-coordinate can be found by plugging the -4 into the original function. So y equals f of -4, which will be the square root of 16 minus a -4 squared over a -4 minus 8. Well, -4 squared is 16. -4 minus 8 is a -12. 16 minus 16 is a 0. Square root of 0 is a 0. So this is going to come out to square root of 0 over -12. Square root of 0 is 0 over -12. And 0 over any non-zero number equals 0. So the corresponding y-coordinate is a 0. Right at the critical number of +2, we have a trend change from decreasing to increasing. That'll make the 2 be a relative minimum. So we have a relative min occurring in an x-coordinate of 2. It'll have some corresponding y-coordinate that can be found by plugging the 2 into the original function. And that will be the square root of 16 minus 2 squared divided by 2 minus 8, which is the square root of 16 minus 2 squared is 4. And then 2 minus 8 is a -6. So this will be the square root of 12 over -6. 12 is made up of a perfect square, 4 times 3, and the 4 can come out as a 2. The 3 will stay inside of the square root. And we can cancel the 2 with the 6. And positive or negative is negative. There's a square root of 3, and it'll be over a 3 after we cancel the 2 with the 6. So negative square root of 3 over 3. And then the third critical number is the right endpoint. And at the right endpoint, there's nothing to the right of it, but to the left of it, it is increasing up to it. So that's going to make the right endpoint also be a relative maximum. So there's a relative maximum occurring at an x-coordinate of 4, and it has a corresponding y-coordinate that can be found by plugging 4 into the original function. So the y will equal f of 4, which is the square root of 16 minus 4 squared over 4 minus 8, which is the square root of 16 minus 4 squared is 16, and 4 minus 8 is a -4. 16 minus 16 is a 0. The square root of 0 is 0 over a -4, and 0 over any non-zero number equals to 0, so it has a corresponding y-coordinate of 0. And so we have one decreasing interval, one increasing interval, a relative maximum at -4, 0, and another one at 4, 0, the two endpoints, and a relative minimum occurring in between at 2 with a y-coordinate of -square root of 3 over 3.